My name is Dawa Osinga. I'm a software engineer in the Sydney office working on Google Wave. Let me begin with the bad news. It seems you all showed up in the wrong room. The party is somewhere else. This is where we talk about the API. Okay, that went well. So today we're announcing, well, really last week, we talk about our developer preview. That is the official launch of Google Wave is still a month away. But we start by giving out accounts to selected developers on Wave Sandbox, which is a version of the more or less latest version of Wave that we like developers to play around with. We'll be giving out accounts to everybody that attended I/O or that attended any of the Google Developer Days. And we've been starting to do that, and you'll receive an email in the next weeks or so with the confirmation. If you go to the form and complete that form, you have to put in your desired username. If you don't do that, you won't get an account. Before you get that email, you can get started on, by reading up our documentation on code.google.com, or you can check out our blog with latest information, and that should get you started. Now, wave building. I have no idea whether this works in Japanese or not. You'll have to hear from the translator. This is the wave building in Australia, which is fitting because today we talk about Wave and we talk about how we can build applications for and on top of Google Wave. And obviously our team was started in Australia about 2 years ago by Lars and Jens, who are also the founders of Google Maps. So they had some credentials. Before we dive into how we can interact as developers with Wave, it might make sense to take a step back and look at the autonomy of a Wave. You have probably, hopefully, seen this morning or otherwise on the YouTube video of Google Wave what a Wave looks like in the client. Well, internally, it looks like this. A wave is a thin envelope that contains wavelets. And wavelets contain two things. They have a list of participants, and they have a list of blips. Blips are the messages that you see in waves. And our client goes ahead, and when you open a wave, and it retrieves all the wavelets that you have access to. Because the key to understanding a wavelet is that one wavelet has a set of permissions for the participants that it has. So that's the way that we handle participants in Google Wave. So in this example, there's 3 blips that are accessible by 5 participants that you can see in the corner. And these 5 participants discuss where they should go for dinner. And one person suggests, let's go get pizza. And then the other says, OK, that sounds good. But then you see there's a second wavelet that only has 2 participants on them. And those 2 participants say, hey, I'd rather get Mexican food, so let's bail. So those people are not actually communicating that to the other people. So the client would render this whole story as a wave visible for everybody with the 3 blips, and then this inline private reply conversation for the other 2. In Google Wave API, we split it up in 2 parts. We have the parts of embedding that we'll momentarily talk about, and then we have extensions. And the best way to look at this is that embedding allows you as a developer to take a wave and put it on a website. Very similarly as to how that works in Google Maps. Well, with extensions, you take something from outside a wave, your code, or maybe you integrate with an external source of data, and you put that in Wave. So one way of looking at it is that embedding makes the world slightly better by putting waves in there, and extensions make Wave better by putting a bit of the world in there. Now, the architecture of embedding. It's fairly simple. And again, this is fairly closely, it works fairly the same as it works for Google Maps, which is not a coincidence because the founders of Google Wave are the same as the founders for Google Maps, and they always found that they got a lot of mileage out of providing in an early stage the embedding APIs. So what you do is, as a developer, you include a little bit of JavaScript, and you get that from one of our servers. And then you call functions in that JavaScript. And that results in the instantiation of a version of the Wave client, which is essentially the same piece of code as that you see in your browser, but stripped from all the Chrome around it. So you only get the content of the Wave. And that thing lives in an iframe and communicates over the same mechanism that we use in the normal client setup, and it keeps that thing in sync. We have, right now, the embed API is really, really simple. We only have like 4 methods, and we have plans to make it bigger and more, get it to the point where you can actually use it to have people from the same website to communicate with each other without requiring them to have Wave accounts. But for now, you need Wave accounts in order to interact with embedded waves. So the 4 methods that we have are load Wave, which essentially takes a Wave ID and loads it into the frame. Then we have set UI config, which is a method that lets you configure the look and feel of a wave. Because if you embed a wave, you don't necessarily want that to look exactly the same as in our client. You know, if you have, like this example that we showed this morning, a blog, you want the wave to show up in the same colors and the same font as you use for the rest of your blog. Then we have 2 other methods that let you, as a developer, add a reply on behalf of the current user. You can attach this to a reply button, and that way you can let visitors to your website leave a reply in the embedded wave by the UI that you provide and not the one that Google does. Let's have a look at how that works in practice. This is the shortest code to embed a wave. We start at the top by declaring a div with a height of 500 pixels and a width of the full page. Then we load this library that I talked about before. Currently, it's hosted on this somewhat strange URL. That's because we're still working out where it should go. We'll probably integrate it with goog.load. And then we go ahead and we create a new wave panel, and we host that wave panel on wave.google.com/sandbox. We have to do that right now because since we're still in the developer preview phase, we can't instantiate waves on the public wave site because it doesn't exist. So we explicitly have to say that this is a preview wave. Then we provide wave with the wave ID. Typically, you would get the wave ID from a robot or something else because you would integrate this with the rest of the system. But you can always also go, and I realize this doesn't mean that much to you because you haven't really used Wave, but you will in the next weeks. You can go to the debug menu and get it from there. And then we go ahead and tell the Wave panel to render itself in the div that has the Wave frame ID, which is the thing here on top. So now, if we look at that, I can't find the thing. Wave talk, here we go. So here we have the file that I just showed you, and if we open it, it will go ahead, open Chrome, it's my default browser, so no surprise there. It takes a little while, longer than I would like. And here you see, it the text that it has here, it shows just like a normal text. It doesn't appear at all as a wave because we stripped it from anything that looks like wave. However, if I mouse over the wave, you see that the reply button appear here, and I could actually reply to this wave. Now let's make this a little more interesting. So this is the same example as just before. The only thing that we do is we add a button that we make trigger the add participant event. And we say, hey, leave a comment using this button. And then we have the set UI config, where you can see that we specify to use the Courier New font, take black as a background color and red as a foreground color. So that now, essentially, we'll take the same wave, but we just show that this way we can make it look quite differently. So this is this file. Same story. Again, it takes a little while to load, but now you go, here you go. So you see it's the same wave. It just shows up in a different font. And there's an add comment button. I could go ahead and leave a comment here. Hello from me. And anybody else that would have the same wave open on the same page or in a wave client would see immediately this thing appear. So that's embedding for you. One of our internal developers saw this and thought, that's neat. And what he actually did is he took the embedding code and stuck it into a open social gadget. And that's kind of nice, because what it does, it creates this gadget that you can insert into your iGoogle page or anywhere else where gadget is reported. And you configure it, and you get to see a wave on iGoogle. Now, for example, if you would use Wave to keep your team's to-do list, which is not an unreasonable plan, you could use this thing to, every time you open iGoogle, to have a look at that wave. Or if you are on a social network that supports Google Gadgets, which I understand Mixi does, then you can take the same gadget and that way get waves wherever that is supported. Another example of embedding is Orchid. Orchid is not very popular here, but in Brazil it is really the most popular network. And we had a bunch of Orchid engineers over from Brazil into Sydney, and they spent some time to use Wave as an alternative messaging system. This is not launched, it's more like an experiment, but it shows that you can take embedding and not just use it to show existing waves, but really to bring Wave as a communication platform in a different website. And they even went as far that the participants that you show here, that you can add to this wave, are not actually the participants that I would normally see. They're not drawn from my normal contact graph from Google Contacts. They're actually my Orchid friends. Okay, that brings us to the meat of this talk, gadgets and robots, which together form our extension story. Again, extensions allow us to make the Wave experience better and bring elements from outside of Wave into Wave. Before we take a deeper dive into that, let's take a moment and distinguish the two. So robots are server-side components of extensions that run in the cloud, while gadgets sit in your client. So they are actually normal open social type gadgets. So they just take up a rectangular bit of the client, and that is where they do their business. Robots interact with the Wave. They talk directly to the Wave server and modify the Wave. So if they want to interact with the user, they always have to go directly through the Wave. While gadgets, since they own a part of the UI, they can react directly to mouse moves, keyboard moves, all that sort of thing. So a robot observes and modifies the waves, while the gadget talks to the user and then has access to a small bit of the wave where it can store its state. Let's look a little bit deeper into how gadgets work. this is a straightforward diagram of gadget. In this case, we have 3 clients that all look at the same wave: Alice, Bob, and Carl. Who came up with those names? So the gadget runs in an iframe inside of your client, and it uses the gadget RPC library that you might have come across in other Google applications to talk to the rest of the client, and it updates a bit in the wave XML. So each client has a copy of the wave document inside, and part of that document is used to store the state of the gadget. And every time that the client makes a modification to that XML document, that modification is sent to the wave server. And the wave server receives all modifications of all clients and then does a nifty calculation of what the resulting changes to the waves for each of the clients should be. And it broadcasts those changes back into the client. Now, since the gadgets here writes its modification into this thing, and the client here makes sure that this wave XML document actually gets synchronized with the version on the server, and that gets picked up here, it means that if my gadget here would be a chess game, as we showed this morning, and I make a move, then automatically that move is displayed on Bob's and Carl's client too. Oh. Now, the API consists of 3 bits for gadgets. So this is the gadget-specific API. Of course, if you write a gadget, you get a lot of gadget APIs that are always there because you're just building a gadget. This is a specific wave part of that. So you can, on the top here, through the wave object, you can get to the state of the wave, which is a JavaScript version of the bit of XML that as a gadget you get to modify. And you can get to the participants on the wave, which gets you to these blocks here on the side. Other than that, you can get the current viewer, which might be useful, for example, if you want to write a game and you want to keep track on whose move it is. And importantly, you can set 2 callbacks. Namely, if the participants change or if the state change, then we'll call you back. And in general, it is a best practice when coding these sort of things to try to do all the rendering work in these callbacks. Because if you do it that way, if you modify the state, then not only do you get a callback, but all other clients that have the same gadget open get the same callback too. And then if you do the rendering in that callback, it shows the same in all gadgets at the same point. We'll get back to that in just a little bit. So the state object has, you can get the keys of the state. Realistically is a dictionary, so it's a key value pair collection. You can get all the keys that have been set so far, and then you can submit a delta. A delta is a dictionary with key values that are the key and the values that you want to change in the thing. And then, think back of the previous picture, we'll send that delta to the server applies it to the global state and rebroadcasts the new states to all the clients that then automatically keep in sync. If you get to a participant either through get viewer or to get participants, you can retrieve from that participant the participant ID, which is guaranteed to be unique and to be stable, or you can get the display name, which is the name as you would call this, and the string that you typically would display. So in my case, the ID would probably be something like dawa@wavesandbox.com. And my display name would be Dawa Osinga. We also provide you with a picture of the participant. Okay. This is the simplest gadget that you could build. It has nothing to do with Wave. It just says, hello, Wave. Now, we add a little bit of magic here. It's still not a Wave gadget, but it's a map gadget if we do it like this. We just include the map API, and on the callback, we create a map element in the center of the thing, and we set that map to 135 coordinates. So if we take that map and we go to, let me kill this guy here. We get a gadget like this. And you can see it's just a a normal map. It sits inside of the Wave client, and there's not really much I can do with it. The thing is that if somebody else would open the same Wave, they would see the same gadget, but if I move my map, they wouldn't see my move map, because we haven't done anything with the synchronizing the state, but we can. So this is the slight variety of the same map. But what we've done here is, in the main function, we set the state callback to state change, which is defined on the top. And what that thing does, it retrieves two keys, latitude and longitude, and it moves the center of the map to those latitudes and longitudes. And the other thing we do is we set the drag end event of the map to submitting a state with the same key and value as we retrieved there, and as the value of that, we specify the latitude and longitude of the map. It should come as no surprise that if we do that, and we load the shared map here, which is really the same, seemingly the same map. Well, let me see if we can, probably. Now if I move this map, you see that the map in the back moves too. And if I had two participants on this same thing, then you see that this state keeps in sync. So if that person had the same map open, then they would see my movements. So it's not a real useful application yet, but you could see how this would allow me to show my friend where I live by showing him how I can get there. And the other thing is that we get playback for free, so we can actually show how we moved through the world using this map gadget. So that's pretty nifty. Now, I want to go a little deeper and show you what we can do with the participant list. So I modified that gadget, and I added code to call the participant list here, then walk through the participant, and for each of those participants, I get the coordinates that previously have been specified, and I create a marker, a normal maps marker, except for that as an image, I specify here the thumbnail URL of that participant. And then I add a little code here that lets you drag that marker around. But I've made it so that only the current user can drag that map around. And if you do that, you get something slightly more interesting than we had before, namely the gadget that you see here. Now, what this gadget is basically our entire team has their avatar projected on the map, and I asked them to, for this presentation, to drag their avatar to the place where they were originally from. And some people did that, and some people just didn't and put them in random locations. I'm pretty sure that David is not from Japan here, for example. So some of the other example gadgets that we have that are available on code.google.com and that you could try out as soon as you get your hands on the account is the chess that we showed this morning, a slightly more complicated maps gadget that will let you actually draw on the map in a shared way. Then we have here a shared canvas sort of gadget that lets you drag around words. And that way you can together write poetry by dragging the words in the right order. Great fun for everybody. Finally here we have Sudoku, which apparently is not only popular outside of Japan. Here in the corner we have a nice example of what you can do with gadgets in rather a brief amount of time, because during our build-up of Google Wave, of course we had a lot of nights where we had to work too. And especially in Mountain View, we worked through the weekend and there was no food, so we got in this habit where somebody would go out and get the food. And we, of course, organized this on Wave. So what happens is we had these complicated waves where everybody said, I want pizza, I want this, I want that. And it all got very complicated. So somebody put together a little gadget that lets you select what you wanted, and then automatically created a shopping list for the person that would go out to get the food. Now, let's talk a little bit about robots. Robots are the other side of the extension framework that we talked about. So I've sort of shrunk the whole client side here into the corner there. And you can see that the client talks to the wave server, and the wave server keeps that state. And it also communicates with a bunch of robots. And some of the robots are Spelly and Linky, our trusted spell checker and the linkifier. But another thing that we've built is a little robot proxy. And the robot proxy, what it does, it takes all the modifications it gets from waves, and it translates them into JSON and sends them to App Engine. And you can build an application running on App Engine that listens to that JSON format. And anytime something changes on a wave that your robot is on, you get a notification for that, and you can react appropriately. You'll notice that I said App Engine and not any random server. For now, that is a restriction, and we think we can get around that restriction relatively soon now, but there's good technical reasons why for now we stick to App Engine, but don't worry. Let's have a look at the robot API. We have the model as we, well, it's really here. We have the model as we discussed with the blips, the wavelets, and that sort of thing. But we've simplified the way that the robot sees this. It's not a complex XML document. Instead, the robot sees the, the wave document that we talk about as in just the text or as a collection of gadgets or form elements. We'll, over time, probably make this more complex so that you can do more complex things. But for now, it seems that a lot of applications actually want to ignore the detailed structure of a conversation because they want to either act in reference to a gadget, for example, because you write a chess robot or something that interacts directly with the gadget, or you want to respond to a form, or you want to respond just to the text of a thing. It just makes things a little simpler. In general, the way that robots work is that they listen for events. They are defined by way of an XML document called capabilities of XML that declares which events they listen to. And then, if an event like that comes in on a wave that your robot is participating in, we go out and call a handler on your server. And with that server, with that event, we provide you the context and the contents of the wave that things are happening to, and you reply by a string of operations. Now, the operations are defined again in a JSON format. To make things a little simpler, we've provided two client libraries, one in Python and one in Java, that abstract a little away from this JSON format, and that makes it a little simpler to do these operations. I'm going to show you a simple robot, the simplest that I could come up with, and it's written in Python, mostly because Python is way more compact than in Java. I could do it in Java, but then I probably need like 6 files rather than 1 page. So let's go through this simple robot. You can see at the bottom, we say that we're interested in the blip submit event. So if I edit something and I press the submit button, then that submit event is generated. And I tell the system, in case there is a blip submit event, call the onBlip submitted method, which is defined slightly to the top there. What we do there is we get two objects here, one the properties and one the context. And we get from the properties the blip ID, and then in the context we look up the blip. Now the blip, as you remember from the schema that I showed, the blip is the actual message in the wave. And since this is the onBlip submitted, this is the blip that was just submitted. And then we go ahead and we get the text of that blip through this interface that I was talking about before that lets the robot see the entire wave as a series of text. And what we do is we look for two strings, this one here and this one here, and we replace them by certain Unicode characters. And then we put the context back into the blip. Now let me demo to you what that does. I'm sure you all guessed it, but if I go ahead here, because the thing is that, and I reply with hello, you'll see that now my smiley has turned into an actual smiley. You also see that it's a very tiny smiley. That's because I use the Unicode character set, and the size of that is a little smaller than would be optimal for a demo like this. It's a good illustration because most people, when they first see the robot API, the first two ideas that they have is either build an echoing robot or to build a smiley robot. So I think the smiley robot is slightly more interesting. Now, let's make this slightly more interesting, and it shows a little bit the sort of thing that you can do with robots by combining it with other external APIs. Because I think the real power of robot programming versus gadgets is that they actually allow you to make bridges. We showed you this morning, if you remember, the Twitter robot that lets you communicate directly from Wave with Twitter, both retrieving tweets from your Twitter account, but also posting to your Twitter account using Wave as a Twitter client. Similarly, you could imagine that you as a developer could build gateways to systems as IM, email, or other social networks. And we believe there's a lot of mileage to be had there. Now, the thing that I have here is also like a gateway, but it's much simpler because, again, it had to fit on one page. So what do we do? You have to imagine that this piece of code sits in the code that we had before, so all the boilerplate has been removed. You only see what is. So what we do, we look for a placeholder of 3 question marks here in the contents of the blip. And if we find that, then we replace the question marks by a star, and we construct a query that is exactly that, but with double quotes over it. Because what we're going to do is we're going to search for whatever the user typed with the triple quote replaced by a star on Google using the AJAX search APIs, which are usually used from the client using JavaScript, but they're actually perfectly good to be called from the server. And so we can use our robot on App Engine to call them. So we call them using URL fetch, which is a feature of App Engine, and then run through all the fragments. And we use this very, very stupid little irregular expression to extract all the bold tags from the result that we get. Because if you remember, if you search for a star on Google, we try to return results with the placeholder for the star in bold, so you can see what it was that hit the star. And what we do here is fairly straightforward. We make that into lowercase, and then we count what is the most likely thing to be returned. Now, you might wonder what it all ends up to be, and I'll show you. Here we have completely. Unfortunately, something is wrong with the avatar of completely. So I can ask things like, I can type a sentence, and any word that I omit by way of this triple question mark will be substituted by completely. So I can say things like, question mark is the capital of Japan. And you see, Tokyo is the capital of Japan. Nobody had expected anything else. So what happened here is completely went ahead and did a Google search, found that the majority of people on the web seem to think that Tokyo is the capital of Japan, and therefore replied that. I can also be more adventurous and say things like, Google Wave is I have no idea what that is. So I'm sure that your translators will make something of it. And this works even in the middle of a sentence. So let's say I am having a conversation, and suddenly I can't remember what the name is of the guy that founded Google, but I remember his first name. So I can say something like Larry, question mark, founded Google. And it goes ahead and says Larry Page. So that's, for a one-page agent, quite useful. One moment, please. We have a bunch of other sample robots that I'll... So, by the way, I don't know who here has seen the video of that we did for I/O. If you haven't, you should really give it a shot. I heard that we have captions enabled now, so you can see the spoken English. Also, you can also read what is being said, because rather than the 20-minute demo that we gave this morning, it's a 90-minute demo, and it goes into much more details of all the different things. So one of those things that it shows is Polly, which is a nifty robot that lets you do polls. Essentially what it does is you add a Polly to a wave. It gives you a complicated form that lets you configure waves, polling. You can then add people to these waves, and each of those people get their own wave with the questions that you want to ask them. After they answer those questions, the results are automatically gathered, and they all get to see the graphs, both of what percentage of the people have answered the questions and what they have answered in nice little diagrams. Bloggy. Bloggy is, of course, a participant that we did show this morning. Bloggy takes the contents of a wave and, using the embed API that we talked about before, shows it on a different website, in this case, a Blogger lookalike website. Buggy. Buggy is really, really a nifty thing. I wish we had time this morning to show it. Essentially, you can select a piece of text in a wave and then click the bug button. And what it will do is it will then take that piece of text and file it as a bug. So in a situation where you're working with a lot of people on a project, you can take this, you can use that very quickly to first gather all the feedback, and then in a triage session, go through all the feedback that you get and file the different things for different users. Searchy. I'll see if I have time to show Searchy. It's integrate with search. That's the other thing that Google does, if you remember. And Tweety is something that we also demoed. It's a bridge between Google Wave and Twitter. Now, as a developer, of course, you're interested in how do I build these extensions, but you're also interested in how do I get users to my extensions. Because more often than not, the answer for this is that we'll provide you with some sort of gallery, and you can put your stuff in the gallery. And then your users will have to find your creations in that gallery. And that's fine for a lot of situations, for example, like for Android or for iGoogle, where essentially you want to find that thing once and then add it to either your phone or to your iGoogle page. But with waves, since you keep creating new waves, you have to have a better way. So that's why we created this mechanism of extension distribution or extension installers. And essentially what extension installers let you do is they let you associate a user action, like insert a gadget or add a participant or create a new wave, with something that we expose in our client. And currently the only two things that we expose are the new wave hook, which is the new wave menu on top, and the edit toolbar. But over the next month, we expect that we'll add more hooks so that your robots and gadget can react to more things. So, for example, the context-sensitive menu is on the right bottom, and keyboard shortcuts are things that we are considering right now. Now, here you can see how this mechanism allows you easily to insert a gadget like this or add a robot like above there. This is the autonomy of a extension installer. It's a simple XML document, and the way as a developer you want to do this is you want to host this extension document on your server somewhere, and then currently, unfortunately, again, you have to go through the debug menu to create such a thing. But we'll provide with better tools to make it possible to create these extensions directly from Wave. Now, let's have a brief look at what we do here. We have an extension, and it has a location, which is, in this case, the toolbar. So we're saying we want to add something to the toolbar. What do we want to add to the toolbar? Well, obviously, we want to add a button. And we have a caption, and we have an image here, which will be the icon of the toolbar. And the action that we specify here is insert gadget. So what will happen is that at that point, we specify the gadget that I showed before a few minutes ago that does the where do you live interaction. Now, let's see if we quickly can show this to work. So this is what an installer looks like. It's a puzzle piece because we believe that to users it is like a puzzle piece. And unfortunately, I have already installed this thing. And you can see that this toolbar here has no ugly buttons. Well, maybe the last one, because that's another extension that I wrote. Because typically we have our UI designers that make all these pretty buttons, and then I need one for a demo like this, and I didn't get around to get one like that. So I can go ahead and click the install button here. You see that the caption here changes from install to uninstall, and now if I click here, you see there's an extra button here, and I could create a new wave, click this extra button here, and the gadget that I was talking about before gets inserted into that wave. So we believe that's a very powerful way for developers to distribute their wave creations among people, because you can either create a wave and add your friends to this wave with this install piece in there, but you could even go ahead and take this wave and embed this wave on your own website so that anybody that comes by can read in that wave what you've built, can use the wave mechanism to comment on it, but can also directly click the install button and then get your robot or your gadget or your whatever directly integrated into their wave experience. That is all what I have for today. We have like possibly 1 minute for questions. And also, I've been told that we have an asymmetry of translation resources, so if you do have a question, you will have to do it in English, because otherwise I won't know what you ask. Thank you.